Hello everyone and welcome to my channel. Today in this section I am going to talk about what is Athena. We'll also look at some of the core components of Athena, some of the limitations of Athena, and how does it overall fit into AWS architecture along with some other components like Redshift and EMR. So let's start with what is AWS Athena. Athena is an interactive query service that allows you to query data in Amazon S3 using standard SQL. So what is this interactive query? AWS Athena is based on Facebook's Presto, and that is exactly where this word interactive query is coming from, which means a UI to simply interact with the data using SQL queries. Now Presto, which is the backbone of Athena, is basically a distributed SQL query engine that is designed to query large databases in a distributed way using clusters of machines. Athena also connects natively with S3. You can use Athena to query data stored in different locations and formats in a dataset that could be in multiple formats like CSV, JSON, Avro, Parquet, or even some other formats. Now there are advantages of different formats as well. For example, Parquet format is much efficient than having data in CSV format, and that is because the size of the Parquet format on S3 is about 80 to 90% less, and the query runtime in Parquet is about 30 to 35 times faster than running in CSV format, which means you are saving about 98-99% of the cost compared to if you are running and storing in CSV format. It is also serverless, which means no infrastructure setup. It is completely managed by AWS and scales up automatically, and there is zero maintenance for the customer. And because it is serverless, that means you only pay per terabyte of data scanned by your queries. At the time when I'm recording, it is $5 per terabyte of data scan for the US East region, and the rate varies based on the region. So as long as your queries are concise enough to not scan huge data sets every time, you can make it more cost and time effective solution than, let's just say, implementing a Presto solution by yourself or loading the data into a data warehouse. Now there are indirect costs involved as well, including the cost of storing the data in S3, or the data transfer costs, or your networking costs, putting the data and the systems into VPC, but those are some costs that also need to be taken into consideration. Let's talk about some of the core components of Athena. Athena, first of all, is not a database, and it does not store your data, but it has its own internal catalog which stores metadata, or the schema of the dataset, which is your table name, column names, or data types. So when you are trying to make a query, it refers to the metadata or the schema to read the data. Well, there is more efficient way of managing the metadata rather than in the internal data catalog, and that's where Amazon came with Amazon Glue. So let's look at what is Amazon Glue. It is a fully managed ETL service with mainly three components. Number one, it has a crawler that automatically scans the data source, identifies the data formats, and understands your schema. Number two, it has an ETL service that basically is like any other ETL service which transforms and moves the data to different destinations. And the third one, and the most important part, it's a data catalog that stores metadata about your databases and tables that is either in S3 or any other ODBC or JDBC compliant data stores. And these tables and databases are stored in Glue data catalog and can be modified using AWS Management Console or simply using DDL statements. The advantage of having Glue Metastore is that you don't have to maintain multiple versions of metadata separately for, let's say, Amazon S3 or Redshift or EMR. You can have a single version of metadata stored and managed in AWS Glue, and all the query tools that you're using, let it be Athena or Redshift Spectrum, let's just say, you can use this metadata when performing any queries. Now let's talk about the data sources that Athena can access the data from. Athena natively supports querying datasets and data sources that are registered with AWS Glue Data Catalog. So in regions where AWS Glue is supported, Athena uses Glue Data Catalog as central location to store and get the table metadata, not only for Athena but for other services as well, like S3, Amazon RDS, or Redshift Spectrum, or EMR, or any other application that is compatible with Apache Hive and Metastore. In the region where AWS Glue Data Catalog is not supported, you can use Athena native or internal catalog as well. Now let's look at some of the use cases of Athena, when we should be using it. So think about logs or stream data or clickstream data, something that you want to analyze on ad hoc basis. That's all part of the use cases for Athena. You can bring literally any and every source of data and connect it with Athena and perform query. But would it be efficient use of Athena? Probably not. So let's look at some of the examples where we should really use Athena. A lot of customers use Athena to do AWS cost and usage analysis, and that is quite common. If you have a new data set and if you want to see if the data contained within it is actually useful or if it's full of errors, then you can perform quick data profiling. You can look at the results and see if it makes any sense. And you will not have to spend any time in setting up the system for that. That's a perfect use case for Athena. Another use case for Athena is very much related to machine learning. So if you think about the data scientists, they spend a lot of time in gathering, pre-processing, or even mining the data than just training the models. Athena would be a great tool in the aspect that data scientists, they can directly run queries from the notebook in AWS SageMaker, which Athena connects to, and bring large quantities of data directly to their fingertips. So shorter time to results for data scientists. Let's talk about how it is different from some of the other components like EMR and Redshift. Now we need to understand that this is not an apple to apple comparison. Some customers, they only have Redshift, some have Redshift, EMR, and Athena. It all depends on the analytics requirement and understanding of why Amazon made these services. Let's try to explain that using an architectural example. Let's say you have an application that is writing data to MySQL database on EC2. Now you might want to have a separation in transactional and analytical data, and that is where you can use Redshift to store your analytical data and back it up in S3, which it automatically does. Also, you might hit a certain threshold on MySQL at certain point of time, and it becomes necessary for you to have a data warehouse like Redshift, and eventually you might be moving all your data directly to Redshift, and you don't need to go through MySQL every time. So you can use something like AWS Kinesis Data Firehose to put data into S3 for backup and move it to Redshift. Now the benefit of Redshift is that it can scale on compute and storage on demand and can also support really complex SQL queries. So let's say if you have more and more teams querying Redshift directly, then in that case it becomes slow sometimes, and sometimes the wait time for the results can be longer. That is where companies think about increasing the power of Redshift. That's an obvious step, and include more clusters, but you'll have to keep it up and keep paying for it even if the performance requirement goes down. Now Redshift allows concurrency scaling as well, which means if the query waits for, let's say, 15 or 30 seconds, you can tell Redshift to just go and run it on some extended Redshift cluster and get it done. This is how you can have fixed size cluster but still scale as needed. But let's say that at some point you have a lot of aggregation jobs that are running on Redshift, and eventually that will make it really slow. You can do resizing of the clusters every time if you want, but then you'll have to deal with running all aggregation queries again and again and loading data manually from S3. And that is where you think of EMR or Elastic MapReduce to handle all these aggregation processes. EMR or Elastic MapReduce, that is nothing but a way to build Hadoop clusters on demand and you can scale up or down as needed. It makes it very easy. If you are using, let's say, a custom code to process the data and analyze the extremely large data sets with big data processing frameworks like Apache Spark, Hadoop, Presto, HBase, EMR is probably a right service for you. Then you can use EMR also to throw the data out in Parquet format and store it in S3 for analytical purpose. And EMR is also very cost effective if you are, let's say, doing hourly data load with huge amount of data. And you can also use pod instances in the EMR to increase the performance and keep the cost at minimum. Now with Athena, you don't have to pay when it is idle. You pay only for the queries that you run, and it is extremely fast. Mostly Athena is the simplest way to run ad hoc queries. But on the downside, it does not have the brilliant SQL support that Redshift has. It cannot handle that much complex queries. Then we also have Redshift Spectrum that uses Redshift SQL engine. Redshift by itself reads local disk, and Redshift Spectrum can also read S3. So if you are using Redshift Spectrum, you can blend or join the data from these two different sources, from your local system as well as from S3, and perform combined queries. And let's just say at some point, if you're querying from all these services, from Athena, from EMR, and from Redshift Spectrum, then they have separate schema structure. And you can use AWS Glue Metastore, something that we discussed before, to share the same schema across all the different tables. So you will not have to maintain multiple tables and databases for schema, but only one that will be maintained in AWS Glue. So overall, that is how we would look at different components like Redshift, EMR, Athena, Redshift Spectrum, and AWS Glue in an enterprise architecture. Again, there's no apple to apple comparison, but it's just about the analytical requirement of the customer. Let's talk about the limitations of Athena. Athena can only query the latest version of data on a version Amazon S3 bucket and cannot query previous versions of the data. If the data is encrypted in Amazon S3, it must be stored in the same region, and the user who creates the table in Athena must have the right permission to decrypt the data as well. Athena does not support transaction-based operations such as the one found in Hive and Presto on table data. So for example, many different operations like alter table, drop operations, lock operations, show or unlock operations are not supported. And Athena does not support querying the data in Glacier S3 storage class. And also there are limits on the service quotas for Athena. For example, for DDL queries, you have a limit of 20 active create tables and create table add partition queries. There's also a string length limit, and all the strings are encoded in UTF-8, and that is something which is not adjustable. You cannot increase that. Similarly, there are other quotas where the limits are on the S3 and Glue as well, which you need to be mindful of. For example, you can have only 100 buckets per account in S3. And you might need to consider that because Athena generates a separate bucket to log results. But in this situation, you can request for an increase in up to 1000 S3 buckets per AWS account. So that in short, folks, is all about AWS Athena. If this was helpful, please like the video and subscribe for more videos. Thank you.